So here we go. We're going to do a neural network. We're going to do an xOr neural network. So here's the page, learn xOr, pull test down. Now, notice this one. The reason we're doing xOr is it takes two inputs. Either, if you were doing it in robotics, both inputs would be off, your output would be off. If one of the inputs are on, your output is on. If both of the inputs are on, your output is off. If you're dealing with electricity, if you're dealing with just numbers, it's the same kind of thing. So that's what we're eventually going to test. Let's just see randomly. It didn't even give me an answer. Okay. So we're going to train the network, and there we go. We're doing 408 iterations. Notice this is quite slow. That's because I'm using data sync, I think. I think I could speed that up. So it took 7 seconds to train, and now I got no answers. Let's just refresh that. So we are going to train this. It's randomly picking 528 training iterations. There are the batches happening. And there we go. It took 10 seconds to train. So we're going to test 0 input. And the learned output was 0.02. So that's pretty close to 0. Let's try one that should have a close to 1 output. There we go, 0.997. There we go, 0.997. And there we go, 0.003. So it's working. From 2 inputs, it's getting correct output. It's learned. Now, normally with neural networks, you're going to have lots of inputs and some outputs. So this is the most simplest one I can find. And here's the code, a reminder, ditch that, see if it works with the latest TensorFlow. If it doesn't, oh well, this one will still work. So we're setting up a bunch of constants. Just remember these words, epsilon, hidden units. We're having 12 hidden units. Epsilon is a scalar number that's really small. My 1 is just a scalar that's 1. The input is this double array, and the target is this double array. We're setting up a tensor with the input with a 4x2 array shape, and the target with a 4x1 array. Fully connected weights, these are now variables. I haven't ran into TF variables in these tutorials yet. We're initializing these weights with 2, and this is 12 hidden units was the 12, and the initialization. I've got to have a look at this initialize function somewhere. Here we've got a scalar of 0, so the bias is set to 0 to start with. And here we have the next layer of connected weights. It's going from hidden down to 1. This was starting with 2 and going to hidden. So there's your input. There's your output. Looks like we've got one layer. And our connected bias for that layer is 0. Don't know why those weren't randomized. Here we've got an optimizer, which is the train SGD 0.1. Initializing the weights. Here's an equation. Oh, okay. So that's why the weights were set up with a 0, because now we're initializing them. This you can research. It's just supposedly a good way to initialize them. The number of, where's previously? Oh, you pass to initialize weights. Oh, there we go. Hidden units is the first one. So there's initialize weights. Here's the function. I should have a space there. And it's just setting them up all random-like. Now we have a function calculating cost in this nice TensorFlow format where we're adding the y multiplication with the epsilon log. And then the next thing is the sub with multiplication, my1 subtraction, the output, adding epsilon, and log and sum and negative. So that's an understandable equation where you're calculating the cost. Here's our model definition. We're inputting the x value. Here we're doing a tidy function, so they'll clean up those values at the end, which is interesting because I was wondering if variables actually do get cleaned up. And here's another equation that it's returning with the hidden layer, which was defined there. Here we go. We're training, kind of similar to the last training one. We've got iterations, and we're calculating our cost with the tensor and your model. Notice every 100 batches, we're printing it out. There's data sync, which is possibly why this is going slower. It's also returning a data sync instead of data. This is allowing the next frame of the for loop to happen when it's ready. That's why it's got the 08 there. Now here we've got learn and test. So this is the training one. It's got a performance thing that it's storing. It's setting up the random, how many batches you want. It's printing it out. It's awaiting, that's calling the training. It's stopping the performance, printing out the loss. Okay. When we're testing, same thing, it's got a performance. This should be faster. You've set up an input data. You're setting up a one-dimensional tensor from the target information. And you're running it to the model. Okay, getting output value that you can then print somewhere. There we go. The data, now this is synchronous for some reason, is printing it, and then you can print it in the line. This is to the div 531, which is the div in this thing. Oh, what do we have here? This is, oh, it's the button. So this is the main button, calling learn xOr. Then we have the selection box. So this is JavaScript. When you change the selection box, it finds whatever is given to you and it tests it. It runs the test. And this is the information that's giving. So it's either testing 1, 2, 3, 0, 1, 2, or 3. How it's changing that? Oh, it's giving that to the test. So it's testing the number 1, 2, or 3. Let's have a quick look at the test. Test xOr. There we go. That's where that 0, 1, 2, or 3 is going in. Okay. Quick look at the model again. The model's up here. It's running. It's all connected and adding things. So let's look at running this. Learn xOr. Will it run again if it's already been ran? Let's just refresh the page. Run it again. So 515 iterations this time. There's our loss, 3.3 down to 0.3 down to 0.1. So it's working quite quickly. 9 seconds to train. We're sending that, and it took 34 milliseconds, and it's very close to 1. Send that, it's very close to 0. Notice the time speeds up. I'm not sure if those timings are accurate. Anyway, I hope you enjoyed it.